Hey guys, I thought this was a fun problem and I thought of a fun way to demonstrate it. Let's focus right here. This x in the numerator can be broken out into square root of x times square root of x. Now these two square root of x's match so they can cancel each other out. And now we're stuck with just a square root of x. Now let's focus on the square root of x. The square root of a square root of a number is the same thing as the fourth root of a number. Now let's focus on this right here. We can break this x into 4 fourth roots of x. And then one of these in the numerator will cancel with this one in the denominator. That leaves us with 3 of these fourth root of x. We can write these 3 fourth roots of x as fourth root of x cubed. And now we have a square root of the fourth root of x cubed. That's the same thing as the eighth root of x cubed. And then looking at this x up here, we can break this down into 8 eighth roots of x. And this eighth root of x cubed, this 3 here is telling us there are 3 of those. Now we can cancel one of these with one of those, another one with another one, and the third one with the third one. And we're left with 5 of these eighth roots of x. Or in other words, the eighth root of x to the fifth. And now we have the square root of the eighth root of x to the fifth. That's the same thing as the 16th root of x to the fifth. Is the same thing as the 16th root of x to the fifth. And now to get rid of this 5, we can take the fifth root of both sides of the equation. This fifth root and this 5 are going to cancel each other out. And the fifth root of 32 is 2. And now to get x all by itself, we want to get rid of this 16th root. We're going to do both sides of the equation to the 16th power. This 16 exponent and the 16th root will cancel each other out. So we just have x. And 2 to the 16th power is 2 multiplied out 16 times. That's going to be 65,536. And that is the answer to our question. Let's put a box around it. How exciting.